evening class. Class 12 Physics. Date is 10th May 2020. The topic is electric dipole. So we'll discuss electric dipole today. Here are the two cases that we'll solve, and then we'll compare also the result from two cases. That will be the end of the topic, and we'll discuss a little bit summary also. So let us start from electric dipole. This electric dipole is simply a pair of charges, you can say, placed at a short distance. You can say at equilibrium distance. Why equilibrium distance? Equilibrium distance means effective distance between the pair of charges where they can put their Coulomb force of attraction and repulsion at the same time. Since here is a pair of charge means we may add it here. One is positive and one is negative charge. Pair of charge means positive and negative. Positive and negative. At the time positive, negative, we are not keeping positive and negative. So here is electric dipole. This electric means you can say this is electron or charge. Electric starts from electron only or charge, you can say, and we know that charge is two types, positive and negative. Since here is dipole, the meaning of dipole means di plus pole. Di means two and pole means 2 point charge. Means here 2 point charge, you can say. So if 2 point charges means if 2 point charges of magnitude opposite to each other, but their magnitude should be same. If the charge one is positive and one is negative are placed at a equilibrium distance, we can say this is the electric dipole. I mean to say that magnitude in the sense one should be like suppose positive Q means one should be negative Q. In a figure we can see if it is suppose a negative Q charge and it is a positive Q charge, their magnitude should be same. The charges have the same magnitude but they have an opposite sign. And they are placing at a short distance. Short distance in the sense that they should have their interactions. They must have the interactions. It does not mean that one charge is placed at like a point A and one charge is placed at a point B and they have a distance very far from to each other. No, they should be in an equilibrium distance. When we calculate means little bit what is the equilibrium, the magnitude of equilibrium distance, that also can be calculated. So this is called the electric dipole. The distance of either type of charges also can be measured when this is made as a system. The distance of either type of charges can be measured from the midpoint of line joining of these two charges, means A and B. Suppose AB is a line joining of negative Q and positive Q, and O is the center of A and B. Then we can measure the distance of charge placed at point A and the distance of charge is placed at point B. This is plus Q and this is minus Q. Since I have told you this is the center, then it is of course the distance between O and B and the distance between A and O both should be same. So I am keeping like A and A. And if I measure the total distance of AB, means it should be A plus A, means finally we can write 2A. So of course the dipole have a total length we are measuring twice times of the distance of either charge measured from the center of the point. line joining of the two charges. So this is called dipole. This is called the electric dipole. But before going to calculate the electric field due to dipole, we have to understand the dipole moment also. The dipole moment is simply a vector quantity which have a direction from negative to positive, means opposite to the electric field. Suppose this is negative charge and here is suppose positive charge. This is the line joining and here is the midpoint. Here is the midpoint. You can say O. The distance is A from here. This is suppose negative Q charge. This is suppose positive Q charge. Here is also distance A. And the total distance is 2A. The direction of electric field will be from positive to negative. Positive to negative. Then the direction of the dipole moment. Here will first define dipole moment, then we will write the direction of dipole moment. So actually dipole moment means this mathematically, if we calculate the dipole moment, means this is the product of the distance, total distance between the charges. This is suppose A and this is suppose B. Then the product of the total distance between the dipole and the magnitude of either type of charge. Means you can say simply, I can write P is like product of total distance between the pair of charges means I can write negative Q and positive Q and magnitude of either type of charge. So simply what we can write, this is 2A, the total distance is 2A and the either type of charge means either you can take negative Q or positive Q, but it should be absolute. So it will be 2A Q. So this is called dipole moment. So dipole moment is also a vector quantity. Since this is the A will be a shortest distance between either type of charge measured from the center of the dipole. That's why this is a vector. And any vector is multiplying with the scalar, it will also a vector. So P is a vector and it has a direction from negative charge to positive charge. So we can say that P will be along this direction, is opposite to the electric field. Now students, we have the SI units of this dipole moment. The SI units of dipole moment is very easy to write. The SI unit of dipole moment is, see here, this is a meter, this is a constant, so no need to write the unit of this. This is a constant, this is a A, means it can be measured into meter, and this is a coulomb. So coulomb meter. In short, you can write C. Not C finished, this is a coulomb meter. So dipole moment, once we know the dipole moment and the dielectric dipole, then we are able to find the electric field due to the dipoles. And here we have two cases. Here only I discussed the two cases, then we will go for the calculations. So see here, it is the axis of the dipole. This is the axis of the dipole. Okay? Or you can say, if I am drawing a line from A to B such that it will be parallel to the horizontal direction, or you can say if I draw here the axis along the x-axis, if I write it as axis, x-axis, and this is this as a y-axis. So along the x-axis, so this will be considered as an axial line. And if I draw the one axis which is perpendicular, one line perpendicular to the line joining A and B. So this will be the equatorial point. So there are the 2 points. One is here and one is here. P be the any point where we need to find the electric field. Suppose then P may be lying along the direction of AB and P may be along the perpendicular direction of AB, or it will be perpendicular to AB. Why I am telling this? If you are able to measure the dipole, the electric field along the direction of AB and along the direction of suppose OD, then you are able to measure, then you can say that you are able to measure the electric field along the 0 degree direction and along the 90 degree direction. If you know 0 to 90, the variation of field means again you will be able to calculate 180 degree and further. So this result will be very applicable. Okay. So we have 2 cases. One case is along AB and one case is along OD. So let us see that how we'll do this. So electric field. Oh my God, it's a permanent marker. Okay students, first we will measure the electric field due to dipole. Here the case will be electric field due to dipole along axial line. As I told you before, along the direction of AB you can say that. And in exam there may be the questions, they will be asking that find the electric field due to a dipole when the point P is lying along the direction of axis of the dipole, or it making the 0 degree angle. Then immediately you have to understand that we need to find the electric dipole along the axial line. So suppose this is a charge here, so negative charge Q placed at point A, and B is another point where some positive charge is placed. Here O is the center of the line joining of the dipole A, placed at A and B, means you can say the charges are placed at point A and B. Then the direction of electric field will be from positive to negative, and the dipole moment is from negative to positive. Suppose this is a point P. You should not confuse. This is dipole moment also is written here P, but I have written here small p, and this is a point P. I have written here capital P. So P is a point where we need to find the electric field due to this electric dipole. So then from the center we have to measure this point. So let us say that this is R, the R distance. And you know this is the distance means A, and here also this is the distance A. The total distance of dipole is 2A. Then we have to measure the either type of charge to the point D. So from A, this will be I think R plus A. Yeah, R plus A, and from B it will be R minus A. R minus A. So now students, it's very easy to calculate the electric field at point P due to negative charge as well as positive charge. So first of all, we write the electric field at point P due to negative charge. So electric field here, electric field due to negative charge. can be written as 1 by 4 pi epsilon naught charge by square of the distance. So the square of the distance means r plus a whole square. R plus a whole square. The direction if you want to write means this is negative charge. So it will be along the direction of BA you can write. Along the direction of B. Along the direction of B. Now here, why epsilon naught? Suppose this system is placed in a air. And as you know that in the Coulomb's law, if we are keeping a charge in a vacuum or in a air, we are taking the permittivity of the medium is epsilon naught. Its value is already I have written in many videos, that is 8.85 into 10 to the power minus 12 SI unit we can write. Now then after we have E plus means electric field due to positive charge. So electric field due to positive charge means what can we write? 1 by 4 pi epsilon naught, this will be Q. We have to take the magnitude of the charge only, no need to take the sign here. So Q by R minus A, because the distance between distance between this negative positive charge and the point P is R minus A. So this will be R minus A whole square, and simply it is the direction of A. Now, so electric field due to negative charge, electric field due to positive charge, and they all are along the direction of AB. So we have to find the resultant ones. So to find the resultant ones, what we do, we are just taking, if one direction you are taking a positive, then one direction we have to take the negative. Then what we do, we'll subtract, because here the one vector is acting along this direction and one vector is acting along this direction. So what we do, we just take it EQ as a positive direction. So here I write resultant field at P is E say, then the E can be written as E plus Q vector minus of E minus U vector. Then minus sign will be plus. Why I have taken this minus? Because it is acting opposite to that of the E plus, and both are the vectors. And now we have to find the resultant ones. So minus sign will come. So minus it will be plus. And then what we can write here? E plus Q plus E minus Q. Then now you can put the results. So 1 by 4 pi epsilon naught. Directly we can take a common. Since Q by 4 pi epsilon naught it will be common. So Q by 4 pi epsilon naught is taken as common, and the result will be, the remaining will be R minus A whole square and plus 1 by R plus A whole square. Right? Now only we need to solve here. The nothing is there, now only the mathematics is there. So this mathematics easily can be done. I will do also here the C. This mathematics is very easy to calculate. I am dropping all this, and here I am writing. So E will be Q by 4 pi epsilon naught. Now you see, if you take the LCM of these two, it will come R square minus A square whole square, right? And then it will be R plus A whole square here. So R square plus 2AR plus A square. And then here plus, so it will be R square minus 2AR, then plus A square, right? So here this 2AR and 2AR will cancel. What are they? R square. Yes. So then what we write now? This is 2A square one is mistake here. Sorry, here in a 4 you can correct it like here. I'm missing the negative sign because we have to use a negative sign also whenever we are using for the negative charge. For the negative charge, sorry, minus sign will come here. So once again I am declaring here E plus Q. When we are writing E minus Q, E minus Q, the value will be E minus Q, the value will be here minus Q by 4 pi epsilon naught. Here it will be R plus A whole square. So you can add it minus sign, then minus sign will come here, and then finally E will be calculated as Q by 4 pi epsilon naught. 4 pi epsilon naught. Then it will be here R square plus 2AR plus A square. Then minus sign will be here R square minus 2AR plus A square. Then it will be R square minus A square whole square. So now this R square and R square will cancel. This A square and A square will cancel. Minus minus plus, so it will become 4A. So it will come Q times 4AR by R square minus A square whole square. Right? Now if I write 2 times 2AQ times R by R square minus A square whole square, this will be E. So what we get the result? 2AQ is the dipole moment, so it will be 2P dot R by R square minus A square whole square E. This is your result. This is your result. Again, we can change this result in terms of sort dipole. Since dipole is itself is a sort. Dipole itself is a sort, but even when we compare the distance between A and B in comparison to the distance chosen for the point B from O, then what we get, the R is going to be very very high than the distance between A and B. Then obviously the distance between O and B or O and A itself, it will be very very smaller than this R. That's why what we say, since R is very very greater than A, then R square is also very very greater than A square. Then what we can say, here E will be 2PR, and here R square, A square will be negated, then R square and square will be 4, and so it will be R square 4. Now here 1 by 4 pi epsilon naught is left, so you can add it 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught. So this R and R will cancel, so it will be 1 by 4 pi epsilon naught, then 2P by R cube, 2P by R cube, 2P by R cube. And then the final result we can write here 1 by 4 pi epsilon naught 2P by R cube along the direction of unit vector. So this is the result along the axial line. So we will write here A, E axial. You have to see this video till the end. Then the first expression, little bit small minor changes was there that I have done. Then only you will understand. So please don't stop the video in between. So this is your axial line. This is your result for the axial line. Now I will do for the equatorial line. So students, one small minor mistake has been done there that I rectified. Actually, when we are choosing the electric field along the axial line for the negative charge, then we have to choose the sign also, because it is acting opposite to that of the field. Like suppose one field is acting on A to B and one field is acting on B to A. So we have to choose the negative sign, because I have chosen the 2 times negative sign here. That's why we have to choose the negative sign before. So now that's case number 2. Electric field due to electric dipole along equatorial plane, you can say along the equatorial plane at a point P. Okay, so for this we consider one negative charge to be here and one is positive charge here, suppose minus q. Now and plus q, it is point A, it is B, and here suppose the P point is given. So this is the equatorial plane, so we will connect this and this also will be connected. As we know, this is a positive charge, so field will be along this direction, means away from the charge, and this is negative charge, so field will be inward. So here itself, here is means here the two electric field vector will be acting from the point P. So for this, what we do here, we will connect a line. This we have to measure the point P from the origin. Suppose this is R, and as you know that this is distance A. This is also distance A, and here if this is R, this is A, means this is of course R square plus A square under root, and this will be same because this equilateral triangle. Suppose this is angle theta and this is also angle theta, then of course the resultant of E plus Q and E minus Q also will make the angle theta. So two vectors are acting from the point P. So how we will solve this? This can be solved by using the parallelogram of vector addition. So we can draw one perpendicular from here, They do both the points will intersect, both the lines will intersect at point P. So at point here, and then we can connect here. This is the diagonal will give you the resultant field. So this will be angle theta and this also will be angle theta. So you can say the resultant one is E. Now, if we write the field due to positive charge and field due to negative charge, both will be same because distance is same. But we have to take the projection of field due to positive Q charge along the E, and the projection of the field due to negative charge along E. Then only both the vector can give the resultant ones. So for this, we need to find the components of E plus Q or E minus Q. And if we say there are the two components, one is sine component and one is cos component. So sine component is not useful here, they will be cancelling to each other. So only we take the cos component, or we can say the horizontal component. For this we need to find the value of cos theta. So before only I am finding the value of cos theta. So if you find the value of cos theta, any one triangle you can take, either you can take this triangle or this triangle, that will be same. Since here this is looking as a very small triangle, but it will be similar to this. So cos, if I find the cos theta in this triangle, so cos theta means 90 degrees, so this will be H, this will be P, means perpendicular, and this will be base. So base is A by H. So it will be A by R square plus A square to the power half. Now let us find the value of E plus Q. So E plus Q will be Q by 4 pi epsilon naught R square plus A square to the power half. Therefore, you have the whole square. Then it will be same for the minus Q also. Q by 4 pi epsilon naught R square plus A square to the power half whole square. Now both are same. Then what will be the value of E? So the value of E will be E plus Q is plus E minus Q cos theta. So it will be twice times of E plus Q, either E minus Q. I am writing just 2 times Q by 4 pi epsilon naught 1 by, this will be R square plus A square, and times cos theta means, what is the value of cos theta? A by R square plus A square to the power half, right? So now the final result, or if we calculate this, it will be 2A 3 by 2. So here this 2aq is again for the dipole moment. So simply we can write dipole moment by 4 pi epsilon naught, 4 pi epsilon naught, then r square plus a square to the power 3 by 2 unit vector p. Now students, again I have told also in the previous one topic, this r is very greater than a. Since you see here the distance between O and P and the distance between OA or OB both are the very smaller than r. Since dipole is a very short, it is said to be as a short dipole. So you can say for the short dipole, or you can minimize this equation for short dipole. For short dipole, this r square is very greater than a square. This implies that r square plus a square is nearly equals to r square. Then the value of E, equatorial, I am writing you EQA vector by dipole moment divided by 4 pi epsilon naught, and then it will be r square cancel means it will be q. It will be unit vector Q. This is the equation number 2, and previous one you can keep equation number 1. Now this is your final result for the electric field due to electric dipole along equatorial plane at point P. Means this point P will be given point. And here you can see that the one result you are getting along this direction, the result is E axial is 1 by 4 pi epsilon naught 2p vector 2p by r cube, right? And here is in equatorial, this along this direction means the resultant one, this E is acting by making some angle theta, and the final result at point P is getting like P by 4 pi epsilon naught r cube. So you can compare these two results here. If I see axial is having twice times of equatorial, so on comparing these two equations, I have told previous also, then we will compare these two results, and when we compare these two results, means it is easily can be written as E axial is 2 times of E equatorial. So this is the final result. This is the final result. Students, again if you have not understood anywhere, any point, again you can put up the comments, and that I will rectify. In beginning of the video, you have seen the small mistakes was there. Immediately I have rectified also in this video only. So thank you. In this lockdown period, it is very difficult to prepare the videos. So, and because of the problem of different tools, even we are managing. Hope you will study nice, and you will refer some reference books also, and you can do the work. If you practice it 2 times, 3 times, it is very easy. Then we can write by ourselves also. The languages means you just need to define the diagrams only. Once you have described the diagram, then immediately you can come to the calculations, and here is simple algebra are there and small tricks, so that tricks can be understood. Once again, finally I am telling the summary, means how this electric dipole can be recognized for a long time. So you have to see the summary. The summary means summary. So summaries are: number 1, the electric dipole means the pair of charges. The charges is positive, negative, both have same magnitude. So you can say plus q minus q. One pair is called electric dipole. Dipole moment have the direction from negative to positive. Negative to positive, it is 2aq. You know the electric field. You know the electric field. Electric field means charge by the square of the distance with the SI unit of k or CGS unit of k. Means you can write either 1 by 4 pi epsilon naught, or you can use the value of k is 1, but you have to signify whether the unit you are taking the CGS or SI. So third point means you should know how to write the electric field. So it will be charged by like 4 pi epsilon naught. I am writing in means once you have given the questions means either axial or equatorial what to be done, then axial, for the axial means it is coming from the axis, so it will go in the horizontal direction. So axial means you can say along, you can remember along x-axis, you need to find along x-axis. Equatorial means you can say equatorial, if suppose equatorial is finding means you can say along y-axis, I need to find along y-axis. In y-axis, the field due to positive charge and negative charge will be same, only you need to find the value of cos theta. You need to find the value of cos theta. And along the axial line, whenever we are finding, suppose AB is charge is there, then one field will be acting along AB. Suppose positive Q is acting, suppose AB, then immediately if you take a negative charge means it will act from BA direction, is opposite to that, and once they are opposite to that means definitely negative sign will appear there. That I was missed to write, and then again I have done. So these are the summary of your topic. So once you review this, you will understand. Thank you so much.